let's carry on with the new stuff, and hopefully I'll straighten out the videos later. So, all right, so let's see if I can get this Zoom bar to go away. All right, so secure operating systems. All right, so we talked about this. The kernel is the heart of the OS that has direct access to the hardware running in ring 0, and there are two types of kernels, monolithic and microkernel. The monolithic kernel is the old-fashioned thing. In the early days of hacking, everybody used Slackware Linux, and they laughed at the later people that would have their apt-get and all this luxury. In Slack, you had to recompile the kernel every time you added a new program. And they said that's the way to do it. You had to compile your own kernel. Arch Linux people are still this way. They love it. Linux is very hard to use, and of course it runs faster and is smaller and is better if you're a pro, but it's very annoying, and most of us would rather use something like Debian or Ubuntu that has a bunch of luxury features to make it easier to use. Anyway, so there's a monolithic kernel. The entire kernel runs in supervisor mode. You have to recompile the kernel to add any kernel modules, like drivers. The microkernel is the normal general purpose one. So the kernel can change during running. You can have loadable kernel modules added to the kernel without having to change anything else. And that is the all-purpose easy one to use. All right, so there's a reference monitor. We talked about this before when talking about systems that have multiple levels of security on the same hardware. They have a reference monitor, is the part of the operating system that enforces the security policy by keeping track of who you are and what privileges you have and what privileges are required to access different objects. That's the game here. You require this for levels A and B of the TC-SEC. You must have a reference monitor. So users and file permission in the world of Linux, we just have this read, write, execute, read, write, execute, read, write, execute for the owner of an object, the people in the same group, and others. That's the permission model. In Windows, you have these NTFS permissions, and so you have things like full control, modify, read, execute, and special permissions. And as I mentioned before, the 6 you see there are in fact combinations of 14 fundamental elemental permissions. And if you go into the details of Windows permissions, there are weird situations where you can have strange permission structures that don't fit in any of these 6 categories, but most of the time, that's what you use. You can have privileged programs. Yeah. Yeah. Yeah.
So is the reference monitor a file or a pointer?
The reference monitor is a system. It's part of the operating system, part of the kernel. It's the software that decides, that enforces these rules. So here you have some model where one person has full control and another person has read only. The reference monitor is the software that enforces that. It figures out who you are and whether you're in the category that doesn't. Yeah, so it's a module. It's part of the operating system. Yeah. All right, good. So privileged programs are a huge security flaw and a big deal. If you consider that you're a Linux user, for example, although the same thing applies to Windows, if you're a normal user, there's a password file. It has all the passwords for the system in some form. You cannot open or modify that file. Only the privileged user can do that. But how can you change your password? In order to change your password, you have to write to that file that you don't have permissions for. So you have to temporarily elevate your permissions to administrator long enough to write it and then bring them down again. So they have to have some system for this temporary escalation, and this is what you use, privileged programs. SetUID is the Linux system. You can compile a program, and you can give it normal permissions, but you can also give it the SUID bit, which means if I write the program as root, and save it with SUID permission. Someone who is not root can run it, but when that program runs, it runs as root. It runs with the permissions of the owner, not the permissions of the launcher. And that is what's necessary to allow this temporary privilege escalation. This turns out to be the heart of most privilege escalation exploits. Therefore, all a hacker has to do is find some way to trick that SUID program into crashing while it's elevated, or doing an extra step while it's elevated, or changing a pointer so it writes to a different file than it expected to while it's elevated. And there's an endless series of tricks to exploit this, because there is a built-in process that does escalate you temporarily. And as you can imagine, it's a relatively small trick to trick that into escalating you permanently, and that's how privilege escalation exploits mostly work. So one thing that happened in, I think Kali, in Ubuntu, they greatly decreased the number of SUID files. They used to just throw them all over the place, like sloppy people use full control for everyone, and they greatly decreased the number of SUID files. I heard someone, I think it is Android. Android claims that in the latest version, there are now no SUID files at all. I don't know how they achieved that, but it is a worthy goal. This process turned out to be a lot less safe than people might have thought. Anyway, then there's virtualization and distributed computing. So we all know virtualization. Everything you access on the internet is actually a virtual machine, and most of everything is gradually turning into a virtual machine. These desktops you're using aren't really, but often the people do use virtual machines, but all the servers are virtual, running in cloud environments. The amount of money you save by using virtualization on servers is immense, because you can fully utilize your hardware and you can run a cluster of servers that are not running on identical hardware anymore because they're running on identical virtual hardware. And that saves you a ton of money because you can keep using the old hardware that still works while gradually bringing in new hardware, and all the time you're serving customers and you don't have to update your software. So that's one of the huge advantages. Anyway, so everyone's using it. Full virtualization is where you simulate all the hardware. So you have a real processor and a real network card and a real hard drive, and then you simulate a different network card, hard drive, and everything. So the virtual machine sees completely illusory hardware. This is how you could do something like run Windows on Linux or Windows in a VM on the Mac. The Windows sees hardware with Windows drivers that is all simulated, and then the real hardware sees the real drivers that gets to it. This is, of course, the most isolated model, and it is the slowest and most expensive model. It's going to consume more CPU and more RAM to do this, but you have full virtualization, so the simulated environment is completely separate from the real environment. What's a lot faster, and what's usually done in the cloud, on cloud servers, is ParaVirtualization, where you do not completely separate the virtual environment from the host. You let the virtual environment see the real hardware, in some cases, so it can use the same driver. And in the modern world, we have containers. Containers use something called a layered file system, so the separation between the virtual system and the host is even smaller, and that makes containers much smaller and faster and cheaper, but they are also less secure because they're less separated from the host. And I was amazed when I tried to set up a LAMP server on a Linux machine in a container, and it said, you cannot install MySQL in the container if you also have it installed on the host. And I'm like, holy crap. They're really not kidding it. This separation is not complete. Yeah.
So Parallels and
Yep.
VMware, they're full?
Parallels and VMware are full virtualization. The ParaVirtualization is QEMU, I think, does it. VirtualBox is full. Almost all the things you use on a desktop are full because you want to run a totally different OS with totally different hardware. Yeah, the ParaVirtualization, I think QEMU is ParaVirtualization, I'm not sure. I know cloud providers, you're using different virtualization software like ESXi. And I'm not quite sure which mode ESXi runs in. You might be able to do both. But anything on your desktop that a normal user would use is, of course, full virtualization. Because the whole point is you want to run something totally different. The original reason this all happened is because Mac users wanted to play Windows games. But, of course, there are many other uses now. Yeah.
Let me just go back. So in the ParaVirtualization,
Yeah.
guest has some control of running the kernel system calls. Is that what you're saying?
In both of them, the guest can run kernel code. The question is how many layers of translation are involved in that. And in ParaVirtualization, the guest sees the same hardware and uses the same hardware driver. So it makes the virtual machine smaller and it makes it run faster. In full virtualization, the guest sees totally simulated hardware. So if you try to write to the hard drive, it has to go to a driver for the emulated drive and then pass that to the driver of the real drive and then write to the real drive. But in ParaVirtualization, it would go to the real driver to the real drive directly. And therefore, if you were to simulate, say, Linux on Windows, your hardware would have to have a Linux driver for that model of hardware. This is a huge problem. Linux has less drivers than Windows, although it's a lot better than it used to be. So you can easily have a machine that runs Windows, but when you put on Linux, it can't access the hard drive or the keyboard or something because you don't have a driver. In full virtualization, it wouldn't matter at all because the virtual machine would only see simulated hardware. And so you would simulate hardware that's compatible with Linux. But in ParaVirtualization, you would need to find a Windows driver for the hardware, and to run the Linux virtual machine, you'd have to find a Linux driver for that hardware because the hardware it sees is equal to the hardware the host sees. Yeah.
What is Hypervisor?
Hypervisor is the software that does this. It is the software that simulates the hardware.
Microsoft has an internal server Hypervisor, and I know that something like VirtualBox or VMware seems like it works a little bit different.
They call it Hypervisor. Hypervisor is the thing used by Microsoft's, Microsoft has their virtualization. Used to be Hyper-V, yeah. And so, I mean, the Hypervisor is the software that simulates hardware so another operating system can run. That's the generic term for it. So Hyper-V has a hypervisor, ESXi has a hypervisor, so does VMware. Now, in the early days, very early versions, like about 8 years ago, it was all totally simulated. But now they all use hardware virtualization, so they expect cooperation from the processor because that turned out to be much faster. That's why if you have a student with a really old laptop, one thing you could do is you could get a really old version of VMware or the old Microsoft Virtual PC product from long ago that ran before there was any hardware virtualization. You can do it without hardware virtualization, but it turned out to be so efficient that no modern versions will even run on anything. No, it's just, no, it's independent of these. You can do either of these with or without hardware virtualization.
Would you categorize an old version of VirtualBox like
Oh, old version.
as one of those two?
Yeah, all versions of VirtualBox are full virtualization, and so is VMware and Hyper-V when run on a desktop. Now ESX, I think might actually be able to do ParaVirtualization, but I'm not sure. ESXi. This is basically what enterprise server level virtualization is. All client desktop virtualization would be full virtualization. Yeah.
If you get a virus on
Oh, this is a very good question. That is the VM escape attack. People are very worried about that. Of course, the whole point is you would like to have a security boundary so you can put viruses in the virtual machine and it won't affect the host. That's the goal, and mostly it doesn't, but there are attacks that do escape. There's a series of them. For example, if you turn on shared folders, then the virtual machine can access files on the host and the virus can come out that way, but there's a whole series of flaws. There have been several scares here. I think Kimu is what they use on the servers. There was a flaw that came out about a year ago where it turns out that all the virtual machines used by server farms have virtual floppy drives in them because that's just a default from 10 years ago and nobody noticed. And since nobody had remembered to pay attention to that code, it had a buffer overflow in it. So you could totally escape from the virtual machine through the virtual floppy. And that was a panic. Like a year ago, everybody had to reboot all the servers and reboot all the clients because you could totally do that. You could go from one virtual machine to the host and back in the other virtual machines. If there's a defect, you can do it. And now, because of Spectre and Meltdown, there was another big scandal about a year ago. Spectre and Meltdown, as I mentioned, because of the way multiple instructions are processed in the processor, you can leak out. You were totally able to do this too. And everyone freaked out. And they had to patch them all, and it slowed down all the cloud servers by like 30%. So I know DigitalOcean switched to giving everyone twice as much RAM for the same price. And everybody complained mightily because they had to patch it because, again, there was a VM escape. So there are VM escape viruses that leak out of the virtual machine onto the host and into the other virtual machines, and people are worried about them. Of course, they try to prevent them. There have also been attacks that leak out of containers into the host and into other containers. In both cases, there aren't very many of those. That's why you use them. It's a barrier, but like every barrier, it's not perfect.
How about the main difference between the type 1 and the type 5? Type 2, everything has to be processed by the host.
Oh, yes. I know just in general, VMware is proud of how fast their virtual machines run. And VMware has claimed for the last several versions that VM machines run at 100% of the speed of the host because the machine language instructions do not pass through any delay on the way in. I don't know quite how that's true, but I think that's the issue, is do individual instructions have to get translated again on the way out, or does it go right to the hardware? And VMware Workstation has been claiming for years that they can run at 100% of full speed.
That means the VMware Workstation is technically type 2, but they try to do type 1.
I would think so, but I think there are details that I don't really have straight. I know I read an article that said they actually find tiny little fragments of time between the host's instructions and process in between, and that sounded impossible to me. So there's levels of detail I don't know. Yeah, sure, that's a very good question. And so here's the hypervisor. Yeah, here's type 1 and type 2. So ESXi is type 1 that runs right on the bare metal, but type 2, like Workstation, runs as an application on the OS. All right. So of course, this has enormous benefits. The obvious benefit to end users is you can now run software designed for the other operating system. So if you have a Mac, you can run Windows software. On the server, it means you can have a separation between the virtual hardware and the real hardware. And of course, with vSphere and ESXi, you can now have a running server and you can swap out the hardware underneath it. Your server can be spread across 4 real pieces of hardware, so you can turn off one server and do maintenance on it and swap in another server. You can take your whole running virtual machine from one data center and migrate it over the network to another one. And all this time, customers are receiving service, and the virtual server has no downtime, even when you take down all the hardware, which is bloody awesome. And that's why this turns out to be so valuable that everybody is switching to it. And that's why every server you connect with on the internet is really a virtual machine now. It turns out to be the better, cheaper way to do almost everything. And actually getting a physical hardware machine is rare, and data centers charge extra for it, and you'd have to be sort of nuts to do that. But there are people that will actually rent you a bare metal cloud server if you want it, but most you'd have to be nuts. But it would be very unusual that you really want that. So there are a lot of security issues, of course. If you have many guests running on the same host, then in principle, they could leak out through the host. There's no air gap between them. So if there's a VM escape attack or a privilege escalation attack, then you might be able to leak from one VM to another. That is an issue. There are such attacks. And then, of course, there's blinded by virtualization. Suppose you're trying to connect to a span port on a switch. You're trying to monitor all your network traffic. The problem is you have software-defined networking. Suppose I'm running 4 virtual machines on the same host. When one virtual machine sends network traffic to another, it never goes out the network adapter. It goes from one virtual network adapter to another virtual network adapter. And this is where we get the software-defined networking. Now the routers are virtual, the firewalls are virtual, the network cards are virtual, so the network traffic is virtual. It doesn't pass through real hardware the same way. And this makes it hard to monitor. So it's an issue. There's a similar thing called multipath TCP, which is out there. Now you can have like 3 or 4 internet connections, like Comcast and AT&T, which you might do for fault tolerance. So if one goes down, you have the other. And then you might want to be faster by using them both. And modern, you can configure that now. So when I'm downloading a file, it downloads some packets from this network connections and some packets from that network connection and assembles them, so it's faster. But now if I'm trying to monitor the traffic, I can't put in a tap and find the file. I only find part of the file here and part of the file there. So it makes traffic monitoring more difficult, but that's where we are at.
So what's been done so far within the network? Are you sniffing it or something on it, or how does it work?
Well, the original model, which is what most people do, is they buy hardware taps, which they add to pick the traffic off the wire and then send it to their SIEM module like Splunk or something. But in this case, you would have to have software taps. You'd have to have virtual taps collecting the virtual traffic, sending it to your SIEM. And that's why as you move into software-defined networking, we're going to have software emulation of all the security products, software firewall, software tap, software router and switch. Yeah, that's right. That's right, exactly. I think just like IP version 6 and everything else, the first thing people do is availability. They invent a new product and they sell it and everybody uses it. And then the security comes by a few years later saying, wait, we have to somehow secure that. Everybody says, oh, we didn't think of that. Now that you mention it, of course, it's like IPv6 came out. So everybody could just download BitTorrent and go to porn sites and violate all these security regulations because the firewalls and IDSs and everything were not IPv6 compliant. And even the internet service providers didn't have any way to meter the traffic. So if you paid for a cheap connection, you'd get faster bandwidth just using IP version 6 because they couldn't see how much you were using. So this happens with every new technology. First you make it work, then security comes by a few years behind saying, wait, stop. And you try to somehow build it into your security model. Yeah. Multipath TCP, yeah.
Multipath?
Yeah.
Is that a protocol or is that?
It's a good question. I think it requires hardware and software drivers. I'm not quite sure what you call it. I saw it at demonstration at DEF CON. You have to set this up, of course. I'm not quite sure how many places you have to upgrade your devices to do this. It is sort of complicated. You can do one version of it for a long time, like in Windows. You could gang 2 network connections together. It's been able to do that since about Server 2003. That's done all in the software on your box, if you have 2 real wires coming into your box. But this is at an enterprise level. So it would have to be handled by, I guess, the switches and routers and gateways. Yeah, anyway. So there's cloud computing. Like I say, almost nobody owns their own hardware anymore except for the end user devices. You don't really want to own your own servers because then you have to pay for backup and power and everything. It turns out to be much better to put it in the cloud and let somebody else manage it. So you can get software as a service, platform as a service, or infrastructure as a service. Software as a service means that you can just use a program somebody else wrote, like Gmail. You're using somebody else's computer, but you don't have full control. All you have is a limited set of options they give you, and you're just using them. Platform as a service is where you get something like web hosting, where you are able to upload any file you want, but you don't control the operating system or the software. And infrastructure as a service is like Amazon E2C. You rent something like a Linux machine, and you can now install any, or just bare metal, basically rent virtual machine. You can install your own OS, install your own programs, modify the programs, anything you want. All you're getting is the infrastructure. All their promises will have a certain amount of disk space, a certain amount of network bandwidth and processor, and you can do whatever you want with it. All these are available. Well, platform as a service is like web hosting. That's what I have. I have about 10 virtual machines. This one here that we're using, this one here is my platform as a service machine. Let me bring it up. The one you're using here, samsclass.info. This is my platform as a service. I have a web hosting contract with 1&1, and they maintain the operating system, and they update Apache and everything else. I don't worry about any of that. So I can put stuff up here, and this one I don't think has ever been hacked. Now I have other ones my students attack, like this one, attack. Here's one of my attack machines. And in fact, let me go to the one that's kind of gone. Here's my main attack machine. Okay, this one has a bunch of intentional vulnerabilities like SQL injection and PHP and all kinds of it. And people have hacking projects where they hack into this machine, and they can even pretty much, they can get read and write access on it with SQL injection, and they can sometimes escalate to root. So the more advanced students hack this one like crazy. So it's a separate machine. This is a infrastructure as a service. I rented the virtual machine, I installed my own operating system, or I chose it from a list, and then I deliberately did not update it or patch it. So it would have vulnerabilities that they could exploit. And so stuff happens, and this one I thought my most advanced student was Caitlin last semester. She was right at the top of all the competitions. Now she works for, I think, Verizon's Paranoids team. She's an awesome red teamer, and she hacked my page, and this is what she put up, which, by the way, is a subtle form of mockery from I get a lot of criticism because my web pages are just as good as when I learned HTML in like 1993. And I haven't learned anything new since then. So my web pages are the same as like the old GeoCities web pages. So she put all this stuff up, and this is the one I thought was pretty good. This is how I feel when people hack my web page. Anyway, so she made this thing, and I thought it was so great I saved it. You know, I also put up a hackathon, which is a platform as a service. I got a virtual machine. I installed this thing. This is a deliberately vulnerable imitation of Amazon, and it has a whole bunch of vulnerabilities in it. My students practice hacking it, and Caitlin hacked this one too. He changed the name to Caitlin is on, and she replaced all the products with kittens. And you know, you get extra credit for hacking this. There's a few projects where you hack it this way and hack it that way. And then there's a project where totally hack it if you can, and she can. So anyway, I haven't bothered to restore this. I do have to restore both of these from backups pretty often, as you would imagine, because somebody totally trashes them. But it turns out that the students only trash them about once a semester, and they stay up long enough to get the job done. And now, if you're going to do this kind of thing, though, one thing you think is a real bad guy will take it over and use it for attacks, which I worried about. So I learned to use TC. TC is the Linux command that throttles connections. So I use TC in a cron job that limits the upstream bandwidth to about 100 kilobits per second. So if you infect these machines and try to put them in a botnet and attack somebody, they can't send very many packets. The reason I did that is because otherwise, when I put it up, some bad guy would take it over and the hosting provider would take it down and send me a nasty gram. Your machine got infected. What's wrong with you? You bum, clean up your machine. I'm like, oh, crap. But ever since I put that on there, I can get infected and join a botnet, and it doesn't do enough harm to get caught. Anyway, like one of these machines, somebody put a ping flood attacker on it. And here's a Linux, this is an administration question. You can use PS to see the running processes, and you can use netstat or SS to see the processes tied to TCP ports. There is no command I could find that will show me which process is sending out ICMP. I couldn't find it. I spent hours trying to find which process was sending out this ICMP flood, so I changed my firewall to block all ICMP, so the machine is still infected, still attacking somebody, but the packets aren't getting out, and I just don't care. So, which is the way a lot of real businesses are. This is the zero trust model. You don't really clean up your machines. You're not really sure nobody's on them. You just make them work well enough and cope. These machines, I'm totally doing that because they're getting hacked by everybody. And I just keep them running well enough that the projects still work. And I never really get them back to a clean state. So that's platform as a service. That's infrastructure as a service, where I'm responsible for the operating system and I can make mistakes like not update it and let them get hacked. Platform as a service is what I use for my main website because somebody else is putting all the patches to keep it reasonably secure, and I don't have to worry about that. But that would mean if I wanted to have a vulnerability, I don't have the authorization to create that vulnerability. Anyway, so some people, the most common cloud is the public cloud, like Google Cloud and Amazon Cloud. You're putting it on a server, and that server is shared with other people, and it's available to the internet and everything. This is why a ton of people get hurt by open Amazon buckets. They take their data center, they do images of machines, they send it up to the Amazon Cloud, they say, okay, boss, it's all done, and they didn't notice in the fine print that their servers are wide open to everybody now. They used to be behind firewalls and switches and access. Now they're just available to everybody. So there's a bunch of people finding open buckets full of millions of records of no longer private data. A similar issue is people decide we're going to switch to version control. So we're going to take all our software and put it on GitHub. And what they don't realize is their developers have been putting passwords and encryption keys and security keys in the source code because the source code was proprietary and only on your server. And now you put it on GitHub and everybody can find your secrets in the GitHub stuff. This is happening like crazy too. As you move to the cloud, you take stuff from a trusted controlled environment and put it in an untrusted public environment. And many people don't understand. There was a fun survey about 5 years ago where they surveyed people who were doing cloud migration, and 80% of the customers said, oh, the hosting provider is handling security. And none of the hosting providers provide any security at all. It's Amazon says, no, no, no. The only thing we promised is we will keep the machine running. We provide availability. Security is your responsibility. But 80% of the people said, oh, no, they're taking care of that. It'll be fine. And it's manifestly not fine. Anyway, so that's the issue. And the number one concern holding people back from cloud migrations is concern about security. And they are entirely right about that. Just like when Wi-Fi came out in like the late 90s, most of the public didn't trust it because they said, this can't be safe. My data is just going everywhere. Won't people get it? And the industry said, oh, it'll be fine. We have wired equivalent privacy. You'll be fine. And the public wasn't convinced. And they were right, of course. Wired equivalent privacy was crap. And in fact, everybody could steal your data. And people are correct also here that if I just put all my stuff on a public server, that's not really safe, is it? It's not. You have to put some attention into making it safe. So some people stick to a private cloud where they do want to make it possible for their workers to move, and they put it on a server that can be accessed remotely, but they don't let the whole world in. Yeah.
Do you see there's a sort of industry to migrate people off the cloud?
I think I've heard of that. You know, I think I forgot to start the recording.
Once you get in,
oh, it's running. Good. Okay.
Almost hard to get out of the cloud.
Well, you know, I have heard of things like that. Like I know there was a whole industry of downgrading Vista back to XP and stuff. I haven't heard of that specifically, but I do know a lot of people have failed cloud migrations where they move to the cloud, now they have trouble, and then they hire consultants to help them clean it up. Migrating back from the cloud, I haven't heard of people doing that much, because the whole point of moving to the cloud is to spare yourself the expense of running your own data center, which is really not cheap. This is one other advantage, by the way, of virtual machines. I heard at a conference from VMware, they said in the old days, if you had a department, like I have a sales department, we have a new product, the sales team wants to put up a website, they would have to ask the IT department, okay, we want a web server. The IT department would say, well, that will take us 2 weeks because we have to buy another server, put it in the rack, provide for more air conditioning, stick in the wires, provide for more backup, and it'll take all that time. And he said, now it's 5 minutes. You just make another virtual machine on our platform. And so, you know, if you run your own data center, it is so expensive to do it right. Once you go to the cloud, to spare yourself all that expense of heating and cooling and backups and disaster recovery and everything. You outsource all that. So, I mean, I don't know. Once you've done it, it would be real expensive to undo it.
Yeah, it's really hard to get out of the cloud. That's the thing.
I know. The cloud is very addictive. I remember I used to tell students with ideas for startups, I say, if you are starting a business and you buy a server, you just made your first mistake. You should just put it in the cloud. Put it on Amazon. They'll give you a free cloud server for a year. You should just do that. Don't run your own hardware. That's just making life hard for you, unless you have some special need to do that.
I have a question. So,
Yeah.
Say we're a company and I ask for hours and I get that put on a public cloud.
Mm-hmm.
It is then my duty to put security around, and they would let you. What are your parameters? Do you see where I'm going?
Well,
Because
like,
at
for
some
instance,
point,
well, if you go to the most mature one, which is the Amazon cloud,
Yeah.
then you rent a cloud machine. They give you a machine. Now you can configure a firewall. They give you a software firewall. It's all software defined networking. You can specify what ports you're allowed in and out. And they also have other services you can purchase, like one's called Guard Dog and something called Sentry or something. There's like an IDS. You can buy more security products to put around it. And you can define a virtual local area network and a private network and a virtual router to separate your network and everything. You can reproduce all the security measures from your on-premises in the cloud with virtual stuff, but you have to configure it and pay for it. By default, if you just get an Amazon virtual machine, it's just connected directly to the internet and that's it. And it does have a virtual firewall though, which doesn't let anything through except the control traffic at first. But of course you have to open some ports to get whatever you're getting out. But I mean, they have their version of stuff and you have to learn how to turn it on. That's why you have the Amazon class here. It's a whole marketable skill if you learn how to properly use the Amazon cloud. And here's one fun thing about cloud computing, which I learned from, I think, a visitor, one of the Wall of Sheep guys came and visited me, Muscles. He's very good. He had a brilliant idea. Here's a fundamental rule about cloud servers. If you SSH into a server and log in and type a command, you're an idiot. You're an amateur. You never do that with a cloud server. If you want to change, a cloud server, everything that happens should be completely automatic. You should configure it on your local virtualization, and you should get it so that when it boots up, it automatically launches everything you need, and that's all you do. And then if you want to change anything, you don't SSH in and change it. You change your local copy to a new version, and you push up a whole new virtual machine. This is the way professionals do it. You have to do it this way because the whole point of the cloud is you're going to have a cluster. If you have one machine and then you get more traffic, you make a cluster. You duplicate 3 or 4 or 5 of them, and then you turn off some of them and you move it back and forth. So it has to just be a replaceable identical component. They call this container orchestration. And you should be, now, so that's the professional technique. And here's something that I learned from Muscles, which I thought was wonderful. So Microsoft comes out every month with Patch Tuesday. And you have to patch your stuff. And then they come out with new versions of SQL Server and everything else, and you're constantly changing things. So what most people do is they have a server, and then they put on the patch, and then they put on the update, and then they put on the patch, and then they put on the update. And what happens is mistakes accumulate, and the server gets more and more broken and damaged as it goes ahead and slows down. But what he does is you have a naked install, and then you have a series of commands to install it. This is what Puppet and Chef do. Puppet, if you want to run a cloud machine, the best thing to do is not to make a disk image and push it up. The best thing is record all the commands that create it. So you do a network install of, say, Ubuntu, then you do an apt get to install stuff, then you do a text command line command to change it. You record all the text to make the machine the way you want it, and you just play it back like a player piano. That text file is really small and simple. That's what Puppet and Chef do. You record all the commands. That's why I say if you type into a virtual machine, you're an amateur. You type into an orchestration framework, which then records it, and then you play that record back. And now if you want another one, you just play those keystrokes again over here and again over here, and you have as many as you want. So what he does is every time Patch Tuesday comes out, they make a new image by installing a naked Windows machine and then playing their script to reinstall everything, including the new patch. Now they have a new, fresh machine. Now they push that up. So if the old machine got hacked or infected, those infections are going to vanish. You put up the new one, it's a clean machine plus the patch. It's not the old dirty machine plus a patch. This, I thought, is incredibly brilliant. It doesn't even take any more time, doesn't even take any more resources. It just takes a little more planning. And everybody should be doing that. And I never heard of anybody doing it except this one company that came and visited. But this is the kind of stuff. And here's another one I learned in China from the Wall of Sheep guys. Now there's a problem with security. If you go to a lab like this, where there's all these Windows machines, they were all made from the same golden image. That means they all have the same administrator password. This is a problem. People are addressing this. Now they don't do orchestration, which causes this problem. They do swarming. Swarming is the orchestration thing where you have an image and then you modify the image for every copy so they're all different. You change the MAC address, you change the IP address, you change the administrator password, so they are not all just identical copies anymore. That's the new hotness. Anyway, so these issues come up. So that's your cloud computing. Why is this thing not moving? All right. And so there have been problems. Like I mentioned before, in 2011, Amazon used to have a public repository of user-submitted images, which you could download from Amazon and put on your virtual machine. You could just go, they had somebody put up a Linux image doing this or that, and somebody put up an image with a backdoor SSH key, because it was just like Firefox extensions. It was just user-submitted stuff that was not checked by Amazon or anything. And they came to regret that, just like everybody else, like Facebook. Once you let somebody else put content on your platform, after a while you will realize this is a problem. What if they do something rotten on my platform? I'm still liable for that to some extent. So there's grid computing is another way where you have a cluster of machines and they are not identical. This is what things like SETI at home do. They get everybody to run a screensaver, and they're running on all different machines, and they're all helping to accomplish a big job. So the server parcels up this job. SETI is searching for extraterrestrial intelligence. There's another one doing protein folding. You have some big computational job, and you break it up in little chunks. And they send you one chunk, and your machine does it, and then they take it back. They send another machine a different chunk. So all these machines running different operating systems and everything can independently be contributing to a big job. All right. Now you can have parallel systems. This is where you have parallel processors, but they're all sharing memory between systems. So it can make things faster, but now you can have race conditions where one machine changes something and another machine reads it, but it's been changed. One machine writes something, then they come back later to read it, but another machine has changed it in between. That's a race condition. That's the classic one. When I used to work as a database administrator at an escrow agency, we had record locking for this reason. If a customer would call and change an address, one person at the phone would log into their account and start changing the address. If another person tried to change the same address at the same time, they would get an error message saying that record is locked to prevent this. If you don't have record locking, then two people could try to change the same record at the same time. And when they save it, of course, only one of those saves is going to happen and the other is not going to happen. And that's a race condition, is when you have two processes accessing the same object at the same time, it creates a variety of vulnerabilities. So then you got peer-to-peer sharing, like BitTorrent. BitTorrent is actually pretty wonderful. BitTorrent, you have something like an MP3 that you want to share with other people. And the old system, you just put one copy of it on the server and everybody would download it from the server. But in BitTorrent, you break it up into little chunks, and every chunk has a hash value, so you know if it's correct. And then you share the chunks one by one. So you connect to other people and you say, I've got the first 10 chunks and I need the next 500. So this guy says, well, I have the second 10, I've got the third 10, I've got the eighth 10. You get a few chunks from every person, and then you share chunks with other people. So no one person provided the whole file to any one other person. You accumulated the file with chunks from hundreds of random people, and so it's faster. It's arguably very insecure, and of course the main point of it is to distribute illegal pirated stuff, so a lot of it is full of malware. And also another fun thing is a lot of people install BitTorrent clients, and then they install them foolishly and just share their entire C drive. So you can go into BitTorrent and see other people's personal files and passwords and everything. This is how they lost, I think, Obama's helicopter plans. I don't know if I got that slide here. When in one of the Iraq wars, they went to Iraq and they found Air Force Two specs being sold on the street because the contractor that had something to do with installing something on Air Force Two took those files home and put them on his home machine, and his home machine had BitTorrent on it, and he shared his whole C drive. So this is what Wenho Lee did to get him imprisoned as a Chinese spy at Railroad National Lab. He took files from a mandatory access control military environment and put them on a discretionary access control home computer. And that is a violation of security policy. And the same thing happened with the shadow brokers. The shadow brokers is a fake Estonian. It's actually the Russian military, but they wanted to form a false flag operation to embarrass the government, to promote Donald Trump. So an NSA contractor with the NSA attacking tools took them and put them on his home machine, which was a violation of security policy, and his home machine had Kaspersky antivirus. Kaspersky detected this stuff as a virus and sent it to Kaspersky. The Russian military got it, and they decided, what can we do with all these NSA tools? And they said, what we can do is embarrass the Obama White House and the Democrats to promote Trump, because the Russians wanted Trump or Bernie to win. They pushed them both because they thought, I think quite correctly, that both Trump and Bernie were such extreme figures that if they became president, it would cause great chaos in America. And this is certainly what happened. And they decided that leaking the national security tools would be cool, so that's how they got them. And in both cases, it's because someone took something from a controlled military environment and they put it in a home discretionary environment that wasn't safe, and it leaked out. And then the U.S. military said nobody can use Kaspersky anymore, which Kaspersky is still screaming bloody murder out and saying, we didn't hand it to the government. The government hacked us. We're not bad people. You're rotten bums. But nobody wants to hear it. And then they decided to go after Huawei the same way. We can't have any Chinese stuff on our network, and that's where we are. Arguably, they're correct about the general nature of supply chain attacks. It doesn't make any sense to be putting sensitive data on a machine full of software from other hostile nations and hardware from other hostile nations. That really is a bad idea. Of course, we don't have any alternative. And this is like Europe. Europe, it violates their privacy laws to use American services, but they don't have any local services that provide anything like the same service. So you have to kind of make an exception and break the rules. This is always the way. Oh, there's convenience and security, and this is why the old deal with security measures. They're always saying, don't do this and don't do that. And then people said, you're part of the business, and if you shut down the business and we don't make any money, then what was that security for anyway? So you can't just say no. If someone says we have to use this expensive old hardware like a fancy printer, and that printer is running like Windows 98, this really happens. You buy something, 20 years pass, this thing is totally out of date. So you can tell me I have to patch it or replace it with a new one, but I can't afford that. So you have to secure the one I've got. And so you have to find workarounds. Like, well, you put it behind a VPN concentrator or something. You isolate the network, you make it go through. This is what you do with children, right? Children are vulnerable. They'll just follow a stranger and get in their car and go off. So you don't let them run around. You put them in a fenced yard and you watch over them. You cannot patch them, so you secure them with a layer of security outside them. And that's what a proper security professional does. You don't just tell your boss, no, this can't be done. You say, well, I will figure out how to do that and still provide a reasonable level of security. That's the right thing to do. Anyway, all right, then you got thin clients. If you want to run these desktop machines, have processors and hard drives and everything, but in a high security environment, it would be better if they did not have any hard drives at all. And all they are is just like televisions. They are just a screen and a keyboard and a network connection, and all the data is on the server. and everything you do is happening on the server. This is the wave of the future in a lot of ways. It's also the wave of the distant past in the 70s when this all started, when the computers are so expensive you can only afford one and all you have is a dumb terminal. This is another option. So everything is really on the server and you're just viewing it through a viewer. That's why one high security posture some people do, I know military groups have done and other groups, they just give the employees iPads. And the iPads are locked down so they can't even install anything or change anything, and they work on the iPads and all the data, all the processing on the server. They just have a window onto the server, and therefore there's nothing on this. They can lose it, get it stolen, get it hacked, it doesn't matter because there's nothing on there. Everything's on the server. Anyway.
We've come full circle.
Yep. Well, really, we've expanded, so there are all these options. You can have everything. You have the powerful home machine for your gamer that can do everything, or you can have the thin client like your iPhone, where almost nothing is really on the phone, and both of these have their place. They have diskless workstations, like I say, where everything is just loaded into RAM from the network. And then you got the Internet of Things, where you have all these smart gadgets everywhere, smart thermostats and smart security cameras and everything, and those things are designed to be cheap and designed to use low power and cheap hardware. So typically what they do is take really old versions of Linux and run it on them. So typically extremely vulnerable. And even aside from the intrinsic vulnerability of software, they're typically built with no password or a default password or something like that. And as I mentioned before, they're typically built to automatically accept you as the administrator if you appear to come from the local network. Their only concern is to make it cheap. So it's very insecure, and so there's like a lot of movements trying to do something about IoT security, and a class here in it. There's no simple solution. Yeah.
Can I just share something?
Yeah.
I have a friend in Topo. They have a smart house, which is their vacation home in Miami. A lightning hit it.
Yeah.
They locked them out of the house. So the person who actually takes care of them, because they don't know how to, had to fly in, and the contract says that he can't be on the site alone, so one of them had to fly from California to Miami.
Wow. Yeah.
I just want to tell you.
Yeah, I know.
And she was so upset. She goes, "That smart house is a stupid house."
Yeah.
Spending so much money.
There's another thing I saw. I should mention this actually for cultural enlightenment. By the way, you should all be on Twitter. Twitter is the de facto social network of the security community. I'm on Twitter, and the criminals are on it, and all the professionals are on it. And anyway, there's one of the valuable professional Twitter accounts you should connect to is Internet of Shit. This is it, Internet of Shit. And this is where he does nothing but tweet the disasters of this. Like there was the smart refrigerator where the kids could buy more candy by clicking on the iPad taped to the refrigerator, and the smart washing machine that had a patch. And there was the Nest thermostats where Google decided to just stop supporting them. They just stopped working. They're like, wait, what? And many, many, many of these things. So here, this one is the GEC light bulb. Maybe I'll play this one. This one's been going around for like the last week. This is the GE smart light bulbs. This is the official GE video explaining
to GE Smart Tips. We're going to show you how to factory reset your C by GE bulbs, which will unpair your bulb from other devices and apps that it's connected to. There are 2 factory reset processes, which depend on the generation of bulbs and the firmware you're running on. Here's the first process, designed for bulbs with this package, or for firmware version 2.8 or later. Start with your bulb off for at least 5 seconds. Then turn on the bulb for 8 seconds. Turn off for 2 seconds. Turn on for 8 seconds. Turn off for 2 seconds. Turn on for 8 seconds. Turn off for 2 seconds. Turn on for 8 seconds. Turn off for 2 seconds. Turn on for 8 seconds. Turn off for 2 seconds. And then turn it on one last time. The The bulb will flash on and off 3 times to show that the reset was successful. If it doesn't, your bulb may be running on an older version of firmware and will need to try the second factory reset process, which is designed for C/GE bulbs with this package or for firmware version 2.7 or earlier. Ready? Okay, start with your bulb off for at least 5 seconds. Then turn on the bulb for 8 seconds. Turn off for 2 seconds. Turn on for 2 seconds. Turn off for 2 seconds. Turn on for 2 seconds. Turn off for 2 seconds. Turn on for 2 seconds. Turn off for 2 seconds. Turn on for 8 seconds. Turn off for 2 seconds. Turn on for 8 seconds.
I love the happy music.
Turn off for 2 seconds. And then turn it on one last time. The bulb will flash on and off 3 times if it has been successfully reset. For more smart tips about our smart products, go to cbyge.com.
There was on this Internet of Shit, they had this text message from a house sitter that said, I can't turn off the light in the bathroom and I can't turn off like the burglar alarm or something. He said, oh yeah, the light in the bathroom requires an Android app, but the burglar alarm requires an iOS app. You have to have 2 phones and you have to update them both to this version. And people are like, I was just trying to lock the door. Like, it's a light bulb, for God's sake. This happened. Everybody is so frustrated by this. Like, you have a light bulb and I have to have a PhD to operate my light bulb now. Every time I rent a car, I can't drive the car. I have to stop and Google, what does this beep, beep, beep mean? Anyway, the Internet of Things is a hilarious security mess, as we're all being driven nuts by all our devices being so-called smart. And all being designed by people who think nothing of making it hard to use. There's a fundamental problem here, which I think the CISSP is part of addressing. Technical people make everything way too complicated. I took care of a somewhat handicapped guy for years, and he bought a camera, and I said, did you read the manual? He said, that thing is 100 pages long. And it's true. I mean, what kind of idiot puts a 100-page manual on the camera? They put 100 features in the camera. I said, nobody cares about your 100 features. They want to press the button and get a picture. Don't give me 100 features. None of your customers want 100 features. They want 1 feature that works. That's why Apple is one of the few companies that understands this. Little babies like iPhones. They don't make it hard to use. You have a picture of something, when you poke it, something happens that makes sense. Very few companies have a product usability department, customer experience department. Microsoft emphatically does not. Holy cow. There's a hilarious video when Windows 8 came out of somebody showing his dad his Windows 8, and there's no start button. The keyboard does nothing. What's going on here? He said, have fun with this. The whole world had this response, like, what's wrong with you? I can't do anything. Why do you make everything impossible? And after you learn Microsoft, the next version, they will move it, take away the menu items, take away the options. You spend your life hunting for it. And when you find it, it has a different name. So all my project instructions don't work. Tech people all have ADD. They think nothing of making everything complicated and confusing. And they really need like a advertising human resource customer experience department to protect your product from this nonsense. Yeah.
That guy, Steven Snofsky, got fired right after Windows 8 was
Yeah.
promoted.
Yeah, I know. That's right. They had management structures. There's an internal reason. But anyway, I'm watching this is, I think, big in our society. I think it goes all the way down to the thing I've been worrying about for the last several years, Donald Trump's election. I think there's a whole bunch of Americans that are not on board with this educated, intellectual, complicated stuff and cannot keep up and don't see why we expect all this out of them. And they're increasingly rebellious and unhappy with this intellectual, snobbish culture where they're all deplorables and we're going to have complicated stuff.
If you see a lot of big boards, if you sit on them, they always want a tech person who can explain. They said, please in English.
Yeah.
And you're like, I know I speak different languages, but yes, I'm speaking English. And literally, you have to be able to dumb it down enough that they understand. Okay, the engineers
Yeah.
all of the engineers come and they start to think about it.
I should show you an example, which I don't think I showed the class, but I often talk to people about this. There are two really important products. The less important product in network is Wireshark. Wireshark is a product that lets you see network packets one by one, and it's not really that important, and most people don't use it. It's pretty cool, but a lot of people don't use it. But anyway, this is Wireshark. You have a pretty logo, you have a download link right there. It automatically detects your operating system and downloads the right version. It has videos to train you and a conference and everything right there. That's Wireshark. The much more important product that every hacker uses constantly is Nmap. Nmap you use every time. Okay, this is the Nmap web page. I can't understand a single word. There is no download link. You click this icon, nothing good is going to happen. There is a download link up here. When you click the download link, you have more blah, blah, blah. If you want to actually use, say, the Windows version, good luck. Here you can learn how to contribute source code. Here's the Windows binary in the middle of a sentence. Oh, they finally made it a separate paragraph. It used to be in the middle of the paragraph. This was their huge improvement. There's now a line break here, so you can find the latest release. This is how you get it. This is the most important tool, like the top 5 or maybe the top 1 most important tool for security, and it's just hard to get. And I've told people this is why you need an advertising department. You need to make it look like this and not like that. And I've shown this to technical people, and they said, there's no difference. They're both the same. I don't know what you're talking about. And I'm like, dude, there's a difference here, and the difference is making a difference between going broke and having millions of dollars. There's a really important difference here. And when I go to Twitter, there's people that develop new things and put it up there, and every week they say, I made this great thing, check it out. I go there, there's a GitHub page. There's no README file at all. There's just download links full of software. And like, you know, what does it do? What do I have to run it on? Why should I care? I went to a conference, BitTorrent, and they had this woman giving a talk at the front, and all the smartest people in the world, the famous experts, were in the front row. I was way in the back. I couldn't hear her very well. And apparently it was awesome. They were thrilled. I think she figured out how to hack every PDF file and take over everything, but I couldn't tell what was going on. I never did find out because all the slides were just pages of code like this you couldn't even see, and she mumbled and you couldn't hear anything she said. And I said, there ought to just be a rule that every talk has to start with 2 slides with no code and only 6 words on a line, and you have to tell me, what did you do and why do I care, in English. You probably have to get someone else to write those slides other than the coder that did it, but that's not asking too much. Whatever you're doing, you should tell me, what is it and why do I care? Anyway, but a lot of technical people do not understand that they have to explain that. They're so deep in the woods that they think you're already ready to hear the interesting, fascinating, complicated technical part. And they forgot that you don't even know what it is and why you care. Anyway, and this is part of the CISSP thing. Your manager is not technical typically, and they don't really care about the latest programming trick you learn about manipulating these binary bits in some fascinating way. They just want to know, what does it do for me and how much will it cost and when will it be ready? Things like that. Yeah, yeah. And you won't get what you need unless you translate it into that language. And it is not wrong that you have to translate it into that language. They're doing a job that requires that information. So your job is to translate technical gobbledygook into actionable business intelligence, and hopefully without a lot of insults and disrespect in the process, because they really have to steer the boat. And they're looking at just information and decisions to make that you don't know about. Anyway, so we're at the last cahoots, I think, or well, there's a lot more after this, but yeah, we might do this. Maybe we can do one more section before lunch. All right, so cahoots for A4. See if I can find the cahoots.
You have a good Nmap resource, like all the commands and things like that, or something that
There's a book that's pretty hard to read, and there's there's the man page, the book. Yeah, not as nice as the other stuff. You know, Nmap has a lot of features, and I only use the simple ones. But yeah, Nmap is really important.
Yep. It all starts.
Yep. But you would not know that by looking at the web page. I know. This is the problem. It suffers from a lack of human communication. It's like most technical projects, they have the technical people and they don't have the human communication people, like advertising, marketing, which I used to think is unimportant, and I got over that. It's really important to translate this stuff into human terms. That's why I have students who are not weak technically, and I say, don't give up and leave. There is a role for the non-technical people. There's a really important contribution those non-technical people can be making, which is to help translate this stuff into something a human can understand. Well, we'll see. I thought it might be at least 5, maybe even 6. Good, coming good. We'll see. All right, are you going to join up? Okay, fair enough. If there's more than 3, that makes more sense. All right, if you want TC-Sec level A, what do you have to have? You must have a reference monitor. That is the device that enforces the security boundary. All right. The security risk of virtual machines. VM escape. By the way, there's another one not mentioned here called VM sprawl. It used to be you'd have one server and everything's on that server. Now, since everybody can just rent one on Amazon, you have like hundreds of servers that your IT and your security department doesn't even know about. Parts of your company are just renting a server in the cloud, using it, putting company data on it, customer data on it, and you don't even know that. That's called VM sprawl. Anyway, Canvas. Canvas is an online system where you take quizzes. There's one in this system. So, a course management system like Blackboard. That's software as a service. You didn't install the operating system or the software. You just have a portal, and you can only choose from the options they give you. You're just using software that somebody else wrote without the ability to change it. So which system combines dissimilar computers together? That's grid computing. All right. So let's see how the scores are shaping up. Okay, B has got one. PC has got another one. And FDZZ has got another one. Okay. All right. Well, I think we might as well do one more section before lunch. So, vulnerabilities, threats, and countermeasures. So here's a bunch of emanations, for example. This was the US government Tempest project when people began to realize this was back in the days of the CRT tubes, which had 15,000 volt electron beams tracing things out. And they said, hey, I wonder, isn't that going to emit radio? And as a matter of fact, it totally does. So you can be 30 meters away with an antenna measuring the radio emanations, and you can find out what's on the screen, because it sends a lot of electrons to make a bright dot, then it stops sending electrons to make a dark dot, then it sends them again, and that creates pulses of radio. And so that's why they realized you really need to be in like an underground vault with no windows, with metal all around you when using your computer, or a spy can find out what you're doing from the radio emitted by that device. And everything else, like your CPU is emitting, and it turns out your keyboard send out radio. So there's really a lot of emanations that cause covert channels. Anyway, I'm going to mute people again. All right, and off we go. So, covert channels, like you talk about, covert channels are where there is some information leaving the system that you did not plan on in some indirect way. An attacker can learn something about the system they shouldn't be learning. This is also how people will sneak out their secrets. You can hack into a server, steal the secrets. Now you have to somehow sneak them out of the network. And a covert channel can be used for that. So there are storage channels where you save a file somewhere in some shared folder, which can then be harvested by some other process. There are timing channels where you measure the amount of time it takes to do something and deduce things from that. There, a backdoor is some unexpected way to connect to the system other than the approved way. One common thing is manufacturers often have a secret password that gives them administrative rights on everything so their tech support can maintain it. Cisco is the most notorious one for this. I think 8 times this year, Cisco has had an update because of an unannounced backdoor account in their stuff. Clearly, they've had a culture of doing this that they have not thoroughly erased from their thinking. I know TSA scanners that they use to detect guns in your luggage, those things are running on Windows 98 and they have unchangeable default passwords. Billy K. Rios had a big debunking of them coming out. He's a security researcher. It's a lot of people have unchangeable default passwords and secret backdoors they don't tell you about. It's a very common thing that people do. And of course, it's a bad idea. But there are a lot of people who have gotten a habit of doing this, and a lot of companies haven't got over it yet. I was talking at the with the Wall Street people in China. There's a woman that just got a job as the first security officer ever at a major financial institution. And one guy was there saying, oh, nobody would put a fixed static password in a device anymore. And she said, it's all over the place. If you're the first, a lot of people do it. It might seem obvious, but almost all of the security problems are really pretty obvious. It's not rocket science. It's just doing simple stuff. Then, of course, there's malware, viruses and logic bombs and everything that go on your machine. Then there's 0 days. Like right now, there's a big Microsoft vulnerability for all the older versions that's wormable and spreading around. And it's a 0 day if nobody knows about it yet. So it's not in the antivirus, there's no patch, and there's no way to do anything about it because you don't know about it. That's what the intelligence community uses. And the advanced criminal gangs, they do their own research, they find vulnerabilities, or they purchase them in secret. And now they have, that's what the NSA, shadow brokers files were, which was Eternal Blue and the family, including Eternal Romance, with a series of attacks. They found a vulnerability in Windows. They did not tell anybody. They developed a very advanced weapon, and they used it for years. They could just take over any Windows machine anywhere. And until the Russians stole it and leaked it, they were doing it. And I'm sure that now that Russians leaked that one, they made a bunch of new ones. And that's why I met a guy from Russia, and he said, I used to work at the KGB, now I come to America, and my friends back in Russia are constantly mocking me, reading my email, commenting on my girlfriend, popping up messages on my machine. He said, what can I do? And I said, you can do nothing. He said, that's what I thought. They have access to stuff that will just blast through everything you can get. And I said, you're host. I said, if you booted from an Ubuntu CD, you'd be okay until you logged into anything, and then they'd have you again. I mean, you're toast. And of course, that's the point. That's what 0 day attacks are. Yeah, there's a Mac 0 day, yeah, there's an endless chain of, and the ones you hear about are, of course, no longer 0 days. Then the clock starts counting. It's a 1 day, 2 day, 3 day since it was exposed. And therefore, since you had some chance to stop it by putting on a patch or something. But there's a ton of 0 days, which means nobody knows about it, and there's nothing you can do except general countermeasures like defense in depth, least privilege, blocking unused ports. Those are general countermeasures that might stop them from reaching it, but you don't know what you don't know. Viruses were originally spread by floppies, code attached to an exe file. Most modern threats are not really viruses anymore, although that was a catchy word that caught on. They're mostly worms now. But anyway, a lot of the viruses spread, polymorphic viruses mutate to avoid antivirus, and there are viruses spread by multiple vectors. One of the most famous ones was Bugbear in 2000 that would infect your network, and it would also infect the printer. So when you go around and reinstall every operating system and boot them up, as soon as they connect to the printer, they're infected again. It was bloody annoying. There was also an entertaining race condition at that time where Microsoft had a thing called called Internet Connection Firewall, before Windows Firewall. And this was almost completely useless because it applied to all connections. So if you blocked something on the internet side, it also blocked it on the LAN side. But even if you turned it on, it had another fun feature, which is the operating system boots up, the network connection boots up, and it isn't until 2 seconds later that the firewall kicks on. So even if you configured the firewall to stop Bugbear, when you rebooted the machine, you'd still get infected. It was very annoying. Anyway, worms propagate without being attached to a file through things like email and instant messages. Trojans lie about what they do. The most common kind is fake security products, fake antivirus that just infects you more. And rootkits infect not only the user land, but they affect ring 0 typically, or not. There are kernel mode and user mode rootkits, but what they do is they subvert the fundamental function of the operating system. So what they will do is hook into the kernel so that every time you execute a Windows API call to do something like list the files in a directory, that will be sent to malicious program which lies about what files are in the directory. So a directory will be there that the bad guy is using, and you won't be able to find it, and your antivirus won't be able to find it to scan it. No software will be able to find it because the process that lists the directory has been subverted. That's what rootkits do. They subvert the fundamental operation of the machine. And you can describe them the way Joanna Ruczkowska did, the most powerful rootkit maker in the world, I think, from Poland. Was her small thing, consultancy. She had one called the Blue Pill, where you get infected and it turns your machine into a virtual machine. And now there's another whole operating system and process running on it that you don't know about. And your antivirus and everything are inside the virtual machine. You can't see outside it. She called that the Blue Pill. Anyway, she also put a rootkit. There's a lot of computers in your machine besides the main one, like your NIC has a processor and memory and firmware. So you can put a rootkit in the NIC and you'll never find it. There's no antivirus, you can't scan it. Every component on your machine can be infected with malicious stuff. And the problem with that is it's real hard to make it spread because people don't have identical hardware. So that is more for targeted attacks against an individual. But it certainly is a scary thing. And with the Internet of Things, you could clearly put a virus in that light bulb. That light bulb is apparently so smart that it can crash and you have to reset it. So I could probably put a virus in the light bulb and it could be doing something awful. You know, this is where we're headed. Anyway, the packers are things that like WinZip will make a self-extracting unzip file. So it's zipped, but when you run it, it unzips. You can also just make a packer which encrypts it and compresses it. And the point of this is it bypasses antivirus. So now it looks different, but when you run it, it will unzip. UPX is a common open source unpacker, and we're using it in the malware analysis class. Logic bombs are custom made. They're essentially impossible to detect. This is where some disgruntled insider typically has put something up, like, for example, it could be scanning the payroll system, and when they fire me, it's going to wipe the hard drive. So there was one of these found in Fannie Mae. I don't know if I got the slide here. Fannie Mae had this. They put a logic bomb. Fannie Mae, the huge mortgage broker, government thing, somebody put a logic bomb to wipe out the system, and they found it somehow, which I think is heroic. I mean, you have servers, your administrators are putting up processes and files everywhere. How do you know that one of them isn't malicious? This is part of the great soul searching that hit us all after Edward Snowden. Everybody said, wait a minute, what if our network administrators and data processors are stealing stuff and leaking it and betraying us? How can we defend against that? And that is a really hard question. How do you stop your trusted employees from stabbing you in the back? I don't think there's any good answer, but everybody wants to answer that question now. Anyway, so your antivirus has two techniques. One is signature-based, where it looks for a specific pattern of bytes and flags that thing as a recognized virus. And the other is heuristic-based, where it detects suspicious activity. The problem is people don't like false positives. It's very rude, so they always dial down the sensitivity of the heuristic-based, so it's essentially useless. I had a project I did a few years ago called Python version Norton, where I was making viruses and seeking them past Norton. And I was having trouble getting past one of them. And a guy on the internet contacted me and said, oh, you know how to get past heuristic detection? I said, no, I don't. He says, easy. Just put in a 10-second delay. Because all they do is they launch the thing, the antivirus watches for suspicious activity, but it can't wait too long. So if you wait before doing the malicious thing, it's given up by then. And off you go. And that totally works. Anyway, so you can have server-side attacks where you attack a listening service. This is what the Eternal Blue exploit and the new Windows vulnerability is. If you have file sharing turned on, it will send requests to file sharing, and if there are defects in that software, it can take over the machine. There are client-side attacks where you trick a client into downloading something that is malicious. This is, of course, the most common thing. People download something from the internet, and now they're infected. All right, your web pages are active content. If you view a web page, it is not true at all that you are just viewing something. It's running scripts and PDF files, and in the old days, Flash files, now HTML5 and videos and everything. So you're running code that came from the server, and that's an issue. PHP is one of the handy techniques. A lot of people write PHP. WordPress is based on PHP. A huge resource in the web is written in PHP, and PHP is very vulnerable. And the most common vulnerability is remote file inclusion. You typically have a PHP file and you have a parameter that points to a file name, so you can often change that parameter to point to a different directory or an internet location or a different file, and now you can read or write to the wrong file on the server if they didn't correctly implement permissions. Applets are Java code running on a web server that then run in the context of your browser. This was very popular over the last 5 years. I think people have finally pretty much given up on client-side Java. It's incredibly dangerous, and almost everybody has figured out to just knock it off and use HTML5 instead, which is a lot better. Microsoft's ActiveX was their competitor, where you have compiled code. Windows Update, I think, still uses ActiveX, but it's not very popular on the web anymore because it was also a security disaster. OWASP is the group. It's a open source group. Every company is a member of OWASP. The students and I were the OWASP representatives of RSA about 8 years ago, and we were supposed to recruit new members, and we couldn't because everybody just came to say, we love OWASP, we're already a member. Everybody in the game is in OWASP, and they do a whole lot of things. They have libraries of code patches and educational things, and their most famous thing is the top 10. They have, it's the Open Web Application Security Project, and they publish every couple of years an update of the top 10 web application vulnerabilities. And this is what everybody uses to plan their team. And so this from a few years ago, but the number one was SQL injection or code injection, the worst problem in the world. Before Amazon, AWS open containers, which I think is now the worst problem. This was the biggest problem in the internet. I used to tell my students, if you only know one thing about security, this is it. 99% of all the stolen data in the world came about from this one attack, SQL injection. Because you can steal all the data out of a database with just a few commands in a browser. You don't even need to know what you're doing. It's too easy. And it's been the number one problem since the beginning of this. And then you've got broken authentication, where you don't really keep track of who people are long enough. Cross-site scripting, where scripts intended for one page are executed in a different context and have a different effect. The one I mentioned before with PHP local file inclusion, if I try to access a file by referring to it here, if I try to go to like a password file, ets password, I shouldn't be allowed to go there because my permissions should only let me be in the web folder. But people often don't configure the permissions, so you can directly access a file. This is unsecured direct object reference, where you can, another thing a lot of routers did is you log into the router configuration page with the administrative password, then you redirect to like admin.html. If you just put that in your favorites and come back, you don't actually need to log in. There's not actually a barrier preventing you from getting to admin HTML. It's just that they don't redirect you there until you log in. So if you just go straight there, you can get at it. And this is why people talk about how someone found my students' grades with their social security numbers. It was on the web server. They say, well, you put it on the web server without any permissions, and you just hoped nobody would find it. That's unsecured direct object reference, where something is available, and you just hope they won't find it. Anyway, there's a lot of others here, but that's OWASP is very famous. XML is just a way to organize data and store it. Way to store data, you can send it over the network or have it locally. HTML is a subset of XML. You have these open and closing tags, and a lot of other languages are based on XML. One of the most entertaining one being SAML, security assertion markup language, where you can send information to a server and cryptographic signatures that verify who you are and what your privileges are. And there's a whole bunch of entertaining SAML vulnerabilities where you are able to lie about who you are and trick it into letting you in. I might demonstrate one of them later. Anyway, service-oriented architecture is, this is the problem with the modern world. You have services, you have many services. A typical web page is constructed from like many different servers running many different pieces of software designed by different people from different companies, and very often there are problems as they get combined. So you have XML or JSON data structures moving around. SOAP is the simple way to move objects over the internet, or representational state transfer is a way to put parameters in the URL so they look like folder names. I don't know why people do this. This is one of the many fundamental problems at the web. There are no actual standards of how you send the data to the server. You can put the data in different formats in the request to make it hard to scan. And then there's web services description language, which is a language to explain the inputs and outputs of the services you're offering. I do the Web Application Hackers Handbook. I teach a web application security class, and the fundamental problem is that you are talking to many servers and they're talking to each other, and typically you have administrators that only understand one server, and they secure their one server, and they think it's not their fault if the output of their server is misunderstood by the next server, causing a disaster. And that's what SQL injection is. SQL injection is you have a PHP server that is fully updated, running correctly, and you have a SQL server that is fully updated, running correctly, and the PHP server can be tricked into sending a request to the SQL server which asks for too much data. And both of these server administrators and language maintainers will say, this is not my fault, my thing is running fine. It's like you had a company where this person is speaking English and this person is speaking Japanese. And they tell you something, it gets garbled in translation, and the wrong thing happens over here. But each one of them is doing what they were told to do. Anyway, so databases are where you store large amounts of data like customer credit card numbers and everything. And there are a series of database attacks. And one of them is inference and aggregation attacks. These are threats that happen. I think inference attacks are where you deduce what's there from what's missing. Like, for example, if you have a list of telephone numbers, and remember I talked last time about how people used to use Centrex and there was one number that was used to control the router. So all you could do is go to the phone directory and find out what number is missing, and that's the control number, especially if you just put them in order. That's an inference attack, where you take the unsensitive data and you deduce the sensitive data from it. And an aggregation attack is similar, where you guess something, and I forget exactly how it works. Inference control and polyinstantiation are defenses. These are ways to reorganize your database to protect against these attacks. So a primary key is a unique identifier. You can't identify customers or employees by name because two people might have the same name and people might change their name. So you like to use a social security number, but you're not allowed to do that unless you're the government. So you have to assign them a unique ID. Safeway gives you an ID and everybody else does. So now you have some unique identifier. Polyinstantiation is where you allow two rows to have the same primary key, but they have two different sets of data depending on your privilege level. So the same ID number points to an unprivileged record and a privileged record. This is how you prevent people from deducing where the privileged records are by finding which number is missing. You actually have the same number point to two different pieces of data. It's kind of a cute trick. So inference is where you infer information, like I said, by looking at low privileged data, like watching the pizza deliveries to deduce a military activity. And aggregation is where you use many low-level facts to deduce sensitive information. These are ways for high-security data to leak out through a low-security channel. So you can, here's some controls. You can place the pizza vendors under NDA. So if you want to sell pizza to the Pentagon, you must sign this document and not tell anybody how many pizzas were ordered today, that sort of thing. All right, data mining is this general category of searching through a large data to find the goodies. Typically, people think about it in terms of advertising, how to find people to bother with spam email. Maybe we should quit. I don't want to make you guys late for lunch. You want to go to the next iClickers before lunch or not? Any votes? Apathy reigns. Well, I guess we'll just finish up. It's easier to remember where we left off. So anyway, all right, data analytics is another way of using these large databases. So there are countermeasures for defense in depth. You can have multiple overlapping controls, administrative controls like policies and such. These are ways to protect your database, limitations on these things. Then there's mobile devices. People are carrying around iPads and thumb drives and laptops and everything, and those can bring in malware. They can also have secrets leaving your company as they copy out of there. So you can have administrative controls where you tell the students no cell phones or something. Good luck with that. Technical controls are another option. You can make it so there's an IEEE standard for USB drives. So you can put a signature on the drive, and now only the official company drive will be accepted. Windows 10 has this ability. You can list the official signature that must be on a USB drive, and no other USB drive will connect. That's one control. I know when the Army started using USB attacks, their solution was to use superglue to block up all the USB ports to stop people from bringing USB malware. That's a low-tech version of the same thing. All right, and there are other kinds of control here to allow only trusted devices to connect to your network. So if you want to prevent people from stealing your data, You can back up the data on a mobile device. That will prevent you from losing data on the mobile device. And then you can use things like full disk encryption and remote wipe to try to make it so that even if someone steals the mobile device, you have some countermeasure. Of course, it's not perfect. Here's something people have told me. If you turn on remote wipe and remote administration of like tablets and phones, something like 10 to 15% of all the tablets and phones that vanish will never again connect to the internet. So you'll never get a chance to wipe them. So this means they're either stolen by smart criminals that put them in airplane mode and steal the data, or more likely, they're really lost. They're in the seat cushions. They're not actually stolen. But the problem is you want to testify to your governing body, I really secured the data, and you can't say I wiped the data. I was never able to wipe the data. I don't know what happened with it. It's uncomfortable. But that's why remote wipe is a disturbing feature, because the other thing that worried me immediately about remote wipe is even if they do remote wipe, how do they know I didn't copy the data before you remote wiped it? So remote wipe is an iffy measure. It's of some value, but it's not as valuable as you'd like it to be. Anyway, we got some cahoots, and then we'll go to lunch, 4A5. 4A5. Here it is. Okay. All right. Okay, what does the FBI want to do on the iPhones? Big issue. They want backdoors. They want a secret backdoor on all the phones so they can get the data. And there's huge storm brewing in technology about whether to let them do that, and if so, how. What threat destroys the system on a certain date? That's a logic bomb. Good. Which language has LFI vulnerabilities? It's local file inclusion, the main problem with PHP. Which organization has the top 10 list of web vulnerabilities? WASP. Okay. Which attack searches a large database for useful information? All right, that's data mining. Okay, so let me record the winners. FTZZ again, and Jane, and B. All right, so that's good. I'll stop the share, and we'll be back at 1 for you remote people. And I'll post the video in the meantime.